Recording. Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream on Twitch. No engines, no libraries. It is literally a complete investigation of every piece of code that makes a game tick, right down to the most minute detail, and all the way up to the highest level stuff. That's our goal here on the stream. That is what we do. And right now we are in the middle of doing something that's actually kind of interesting, and we're almost done with it. It's our prototype ground texture. Basically what we're doing is instead of having like a tileable ground where you just kind of walk around and the ground always looks the same, what we decided to do was make it so that we would have sort of an infinitely non-repeating ground that's different everywhere you go. And that we would have the option sort of like we would have like an architecture in there so that as the game progresses, when we're actually developing the mainline game, it'll be easy for us to kind of put stuff into this ground texture as necessary, and work with it to sort of change, what textures, sort of what it shows and that sort of stuff. And we've done a bunch of the work for that, but there's still a little bit left to do, and so I would like to get that finished up this week, and we've got today and tomorrow to do that. And so I'd like to jump right in on that right now. And you can see when I run it, you'll be able to see kind of where we're at. Now, before I begin, if you pre-ordered the game on handmadehero.org, you should have gotten a link in your email. That email link allows you to download the source code. And so if you'd like to follow along with me, please unpack day 86's source code here on day 87, because that's where we're at. That's what I'm working with. And so if you want to match up with what I'm doing, that's what you want to do. All right. So let's take a look at the state of things here, just so I can remind everyone where we are. Oh, and you know what? There's one thing that I want to do before we get started. I lied. Somebody pointed out in the forums that we have a typo. A lot of times, like I said, I make typos on the stream because when I'm talking, when I'm coding, it's hard to pay attention, and there's some typos that sneak in there pretty regularly. Maybe not one an episode, but sometimes one an episode, or even sometimes more than one an episode. So we gotta... I appreciate people's vigilance in catching those because, again, it's really hard for me to do that while I'm talking. This one is bizarre, and I'm going to even step into this here so you can see why this worked at all, because this should have crashed right away when we typed it in the first time. But somehow it didn't, and I feel like it'd be nice to just show why it didn't, because I feel like one of the things that, again, we try to do on the stream is show how memory works and really get you comfortable with working with the memory yourself. And this is kind of a good example to just show, like, wow, okay, so weird stuff can happen when you're just talking about, like, memory, using memory directly, right? Because it really is just a big old flat space that you write into and that you have complete control over. It's not like in higher level languages where you have to always obey all these rules that it sets out for you. Like, it's pretty much anything goes, and so you can do whatever you want. And so what's kind of interesting here is if you take a look, I'm gonna set a breakpoint here and step into the code. We just quickly threw in the code to initialize the transient arena that we were using. And if you notice, what what I typed was incorrect. This was supposed to use the memory for the transient storage, but instead it just used the actual storage size, right? And so if you think about it, this should not have worked at all, because this is not memory. This is just an integer somewhere, right? And we're using that integer as if it was a pointer to some memory. Does that make sense? And most of the time, the reason we don't really have bugs like this hardly ever on the stream is because most of the time we have ways of pretty carefully checking to make sure that we don't do that. But in the case where we first initialize a memory arena, obviously we're going from nothing to something, so we kind of have to cast it up. And so we can make a mistake there. But why did that work at all? And the reason that worked at all is kind of interesting, right, if you take a look at it. So if we take a look at our transient storage size, now it just so happened that the transient storage size we picked, right, happened to be 1 gigabyte of memory. That's just the size that we decided to pick for, here in our debug session, right? That's what we were doing, is a gigabyte of memory. We didn't pick it for any particular reason. We're not using nearly that much memory, but that's just what we picked for a flat array to play with for now. So basically what's happening is the transient state is getting initialized to point to something at the 1 gigabyte boundary, right? That's what's happening. Now, if we look at sort of this at what we've got here, it's a little bit odd because really we shouldn't have been able to access anything that was at that 1 gigabyte boundary, right? Because if you take a look at where our stuff is, our permanent storage and our transient storage, the actual memory that we've reserved is nowhere near that 1 gigabyte boundary. So something that has been legally allocated is sitting there, right? It's basically pointing to some page that's actually valid, and we're just flat out using it. We're overwriting something right now, and we have no idea what. Now, it could be something that we allocated prior, right? It could have been something that we were allocating before. And so if you take a look at, some of the stuff back here, I don't know if it's one of these things. One of these things might have been there. That wasn't. We also had, there was another virtual alloc for like bitmaps and stuff. So I don't actually know what was there. We have no idea what was actually there. And it's not really super possible for us to find out because it could be some, just random stuff that we allocate in the operating system. I have no idea. But because there was nothing there, it actually lets us access that. Right? We're totally allowed to write into that without crashing, and we actually use the state that was there. We actually use whatever was there and make some stuff, right? Which is crazy. So that shouldn't have worked, but it does when that memory happens to be legal. Now, it should be the case that that memory will not always be legal. Like, this should crash on other people's machines, potentially, or just a different run on this machine, and we just got very lucky there. So really, that should have crashed. It was pretty odd that it didn't. But unfortunately, there's not that much you can do. At init time, when you're first building your memory, you got to be careful because, you can pretty trivially make that mistake because you're doing a cast there. Most of the rest of the time, we don't do casts, so we get some protection to make sure that we're not doing something ridiculous like casting an int like that. But anyway, so what we really wanted here was to use the transient storage pointer, right? Then say, is that initialized? And then when we initialize the arena, we wanted to, again, use transient storage, not the size, to point to where we were going. And I believe that's the extent of kind of the typo that had snuck in there. We're just using the size instead of the thing. And again, that won't actually change the running at all. It's just that should have crashed. It didn't crash. Because we got, I guess, unlucky, really, because we would have preferred it crash right away. We would have been like, oh, yeah, whoops. So anyway, let's get back to what we were doing. So what I was saying before is we wanted to produce an endlessly tiling ground texture, and there's two things we haven't done yet to finish that up. As you can see, there is a ground texture beneath us right now, and it is different everywhere, but it is seamed, right? So you can see the seams between it. So the first thing that we'd like to be able to do is turn that ground texture into from something that has a seam to something that is seamless, right? So that it always lines up kind of with its neighbors and doesn't ever show like an artifact at that boundary, right? That's actually pretty easy to do. I know it sounds a little bit difficult maybe at first, but based on the way that we've architected things, I don't think that's going to be particularly difficult, so we're going to do that first. But then we have another thing to do, which is going to be a little more of a think through, although we could just, again, do a pretty basic implementation now and come back to it later when we're doing more performance optimization. Again, you'll also notice that frame stuttering there. That's something to keep in mind. That's when we are building new ground textures. Like I said before, another thing that we're not going to do for a while, this is totally performance stuff, again, is making that happen in the background overlapped. But we're not going to tackle that for a while. So anyway, after I go relatively far, actually, I've got a ways to go here, because we maybe set that number of cached ground tiles a bit high. But right now, we never evict any ground tiles from our cache. So basically, eventually you get to the end, there are no more ground tiles to fill, and we run out of textures, right? So what we need to do as our second thing is we need to be able to evict old tiles that were back kind of, at the start that we didn't actually need anymore when we got here. We need to be able to evict those out of our texture cache that we're using right now to cache those ground buffers. We need to get rid of those, and then we need to generate new ones for these areas. So obviously we know how to generate the new ones, we just don't have a thing that actually evicts. So that eviction scheme is going to be the thing that we do. All right, so let's talk briefly on the blackboard. It's really, like I said, pretty simple, actually, the first thing we're going to do. So let's talk briefly on the blackboard about what we're going to do to get seamless tiles in, and then I'll go implement it. And then after that, we should have some time to start work on the eviction scheme, I would hope, but again, it depends on how well things go, I suppose. We could run into some hairiness that takes longer than it would otherwise. So, all right, so here on day 87, I believe that's where we're at, right? Yeah, day 87. So here on day 87, again, for those of you just joining us, each day is an hour, so we're 87 hours into the coding right now, it's like our third week of programming, if you thought of it that way. Basically, if you think about work weeks, they're like 40 hours a week of programming or something like this, somewhere there. Or if you only get to program about 30 hours a week, which is actually kind of typical for me. Sometimes I only get to program 20 hours a week because I have to do a bunch of other stuff management-wise and art-wise and things like this. It could be more. But basically, like if you were actually full-time programming all day, so think about this we're in our third week of programming here. All right, so here we go. Here is a tile. And the way that we're constructing these tiles right now, right, is we're splatting textures into them that have soft edges. And by splatting a bunch of things in here, we produce a nice ground texture, right? And the problem that we're having right now is we do that completely irrespective of the hard clip boundary that sort of gets enforced like so, right? And so what we'd like to do is we'd like these to be seamless. So whatever was getting splatted over here, we'd like it almost to be as if we had done that splatting, as well as the splatting up at the top and the splatting here and so on, so that all of the splats in the 8 neighbors actually contributed to this splat, and then it would be seamless, right? If you think about it. Because we know that it's seamless inside, so if you thought of this as just one big splatting region, we know that we could grab out this part and it would be correct. So really, at least right now, all we really need to do to make these seamless is actually do exactly what I just said. Splat an entire 3x3 and only extract the middle part, right? Now, that wouldn't help us at all if we just did random splatting across this. But if we actually ensured that each of these was doing the same splatting that it actually does when it's generated itself, then we know that all of our splats will line up. And furthermore, we know that the composite order will be the same if we always enforce a rigid order when we walk through these, right? So if we always do, upper left, this one, this one, this one, this one, this one, right, and so on. Although really, since our coordinate system is y up this way, you might think of it as doing this one first, then these, right? But doesn't matter. As long as we always do them in the same order, we'll always get the same overlap pattern as well for any given tile. So that's really all we need to do. And of course, the good news is, since our bitmap code already does clipping, we actually don't need to do anything special to do this extraction. We don't need to actually produce this 3x3. We can just still set the clip region here and do the splats, as if they were up here. And ones that don't land in the thing will just get early rejected by our clipping and won't hardly cost us anything either. So that's pretty nice too. So even before we optimize this at all, we're getting a little bit of a bonus there just from the fact that the bitmap clipping, which has to happen anyway to avoid us overwriting memory bounds, will basically take all that out of it for us. So all I really need to do to fix this, I believe, unless, sometimes I'm wrong on the stream, right? When you're programming, it's not a case of you're always right kind of thing. That's not how it works. I wish that was how it works, not how it works. So yeah. Okay, so what I want to do is I want to, modify this right here to basically do, a 3x3's worth while still using the same area for filling the ground chunk, okay? So if you think through what's going to happen here, we're going to use a random seed with our chunk x, chunk y, chunk z, only instead of using them from the actual chunk that's passed in, we're going to introduce new synthetic variables for x, y, and z that we're going to iterate over. Now, we're not doing any z handling here, so actually chunk z, for now at least, and probably for always, because we aren't doing three-dimensional texturing or anything like that. We don't need the z to be seamless. That doesn't even mean anything in our world at the moment. So at the moment, chunk z will stay the same always, but the others, right, chunk x and chunk y, we will loop over now, right? We will loop over those. And the way that we want to loop over those is we want to start with that chunk p that we would have been using, and we want to go back one, right? Then we want to go from there to +1, right? So we're doing, that sort of extra, that 3 across kind of thing. And we're going to do that both in the x and the y directions. And it's pretty arbitrary what order we choose to do these in. As long as we do an enforced order, I believe we should get seamless chunks out of it. But again, like I said, we will have to wait and see. So then we come in here and we do the draw loop exactly the same as we had been doing it. And now it's going to do that splatting in all 9 of the sections instead of just the middle one. Now, what we do need to do, though, is we need to make sure that our center accurately reflects the fact that we're in sort of a different chunk area. And to do that, I think, you know, what I could do here, I'm not sure, this might actually be the easier way to write the loop, is I could just go in here and actually compute these two on the fly and use an offset value here instead. So it'd be like chunk offset y, if that makes sense. And just have that loop from -1 to 1 instead, so that I can do an additional computation with it in here to compute what I want the center point to be. And I'll show you that in 1 second. So I'm just going to move that in here and say that, okay, it's going to be whatever the chunk offset is, like that. That's going to happen in X and Y. You can kind of see what's going on here, right? Nothing particularly special. I'm just reconstructing, but changing the way that the loop offset works so that I can, you know, use it more directly. So there we go. We've got our -1 and we've got our 1, and it's inclusive, so it's going to use -1, 0, and 1 when it does this, right? Those are the 3 that it's going to do, and it's going to do those in both times, so we're going to do a total of 9. All right, so we compute our chunk X and our chunk Y, right? And we could even put chunk Z in here just for completeness so you can see them all easily. And when we have those, I now need to compute the center point, because the bitmap, the actual center, how should I say this? So the actual center of the bitmap per se was actually not being used. I'm trying to think of how to explain this. So previously, I think I need the whiteboard just to kind of give you the idea. So previously, we were using the bitmap center, and we were like picking where we were going to splat by moving out from there. And so since we're trying to do each of these individually, when we say bitmap center, what we really mean is a center of whichever one of these chunks we're on. And so really, I need to kind of change that meaning, right? I need to change this center meaning here to basically mean the center of the chunk we're currently on. So this would be the chunk that we're on, right, if we were in the middle chunk, but we need to subtract 1 in you know, width or in height or whatever. We need to like subtract or add depending on what that offset is, right? And so essentially what we're going to do is we're going to say, all right, let's suppose we started with the upper corner, right? So this is the center, right? This is the center that we were using before. Let's say that we actually wanted to subtract, right, the width and height from that. You know what I'm saying? So we would start up there. And then what we would want to do is add in a width and height that's proportional to whatever the offset is, right? So I want to take the offset X, the offset Y, like so, right? And for each one of those, I want to move width in that direction, right? So if I go ahead and compile this, you can kind of see, in fact, I think we might be almost done. This is a little inefficient, right? Obviously, what we're doing here is saying we're going to move half the width and height forward, and then we're going to move back by the width and height again. So you can see I can just kind of algebraically simplify this. It's kind of like 0.5a minus a. That's just -0.5a, right? You know, pretty simple. And off we go. So I'm not sure if I totally did everything right there, but I think the center is all we would need to change. And then the random seed is just going to be off that chunk, so we know that we will always use the same set of random points each time we go. So let's take a look here. When we do this, we've got our stamp with stamp height. We do a width times height, random unilateral for the offset off of the bitmap center. That seems pretty straightforward. I think we may be done. I don't know. We might step through it and check. But let's take a look at what we actually get when we produce these. Now, again, they take a long time to produce, unfortunately. Well, that isn't seamless at all. All right, so we've still got a little bit of nastiness in here. So let's find out what I did wrong. All right, so let's think about this for a minute. We are still doing... So, okay, so we come through, we do our blitz, we pick our random seed. The random seed should be constant because it's based entirely off of the chunks, the absolute chunk index, which is what we want. That center point should be correct, negative width and height up to the top. Yeah, and then it's going to be whatever the chunk offset is. Oh, no, sorry, that is incorrect. I lied. That was not right. So since the chunk offset ranges from -1, 0, +1, I was overzealous there. I did the computation as if the chunk offset was 0, 1, 2. So that was just dumb. So if we start from the center, this will properly move us back to the upper left one and down to the lower right one. Okay, so let's see where we're at with that and then start debugging, because that was just, yeah, stupid computation error on my part. So let's see where we're at this point. All right, so yeah, that is not immediately obvious to me what the bug is there. It still looks like we've got something relatively significant. Like we should be able to tell, if this makes sense, we should be able to tell if we're getting close by whether the things line up, you know, in a relatively close way, or whether they're still pretty far off. And those look still pretty far off to me. So we have some major logic problem. And unfortunately, we don't have a whole lot in the way of debug services yet. It's still before we've gotten to the point where we write those. So we're still kind of flying a little bit on intuition. But I think we should be able to do it. Again, this shouldn't be too hard. So let's just take another look at it and see. So we know we're doing... Wait a minute. Wait a minute. This isn't being used, people. What? This was just old code. Oh, for crying out loud. All right, well, we need that to work, obviously. That's hilarious. So if we were doing an offset without that, we need the center to be in there, people. Really. I don't know that I want to put an owl of shame up for that. I mean, he's peeking at us right now for not checking, but you know, I don't think he's really there entirely. But yeah, so, okay, that's obviously pretty dumb. And so if we're going to do that offset, what I would need to do is, if we're just doing the offset there, I would need to make that offset be just the upper corner, because it looks like we're using random unilateral for the width and the height. So yeah, I suppose that is an owl of shame. Like, before you go modifying some code, you should probably look at it to see what it does. Like, I just assumed I knew what it did because I wrote it, but I mean, you know, hey, I program all day on a completely different code base, and then I come back to this thing. It's not surprising that I forget. All right, so we are now seamless across X, but we are not seamless across Y. So we're getting closer, right? You can see how that is, right? Does that make sense? So we've still got a bug, and our bug is in the Y. I assume that's because we've got the Y flipped in some bad way, or there's something weird happening with the Y that we are not doing properly. So let's take a look. And the other thing, you know what I should probably do is let's just take one of these out of the equation here so that we can take a look at it a little simpler. All right, so taking a look at this now, we've got, why do we still have grass? Why do we still have grass chunks in there? If I if-zeroed out tuft, oh, because this is doing either of those two. I see. So those were the tufts that we were putting in there. All right, so never mind. I don't even know. I wasn't even looking at the tufts. All right, so if we take the tufts out of the equation, and this is actually building it, so now we know that we're just looking at in here, so we don't have to worry about this guy yet. So let's take a look. What are we doing differently with the Y? So we have the bitmap center. That's the center of the thing that we're stamping. We have the offset, and that's an offset inside the bitmap, and that's getting moved sort of by whatever the center is of the one we're doing. And then we're subtracting away the bitmap center, which is basically the thing that we're stamping down, and then we're doing that draw, right? Now, the center is properly computed as whatever the chunk offset width and height is. It's subtracting that or adding that. That looks relatively sane to me. So I'm not exactly sure why we would be getting a weird result from the Y. I'm trying to think if maybe there's an overlapping problem that I'm not thinking of. Something that has to do with the fact that we're doing Y as sort of like a major, the fact that we're Y major instead of X major. So what I'm going to do as a debugging step is I'm going to flip the Y and the X to change which order they're done in, so I can see whether it's just whichever one's done major. And so you can see that it's not whichever one is done major, right? You can see that that's not the case. And so that tells me very definitively that it's not an order problem, it's not an overlap problem, it's a problem with how we're actually handling the Y. So what is wrong with our Y handling? What's going wrong here? Let's see. When we do our chunk Y, that looks correct to me. When we do our width and height here, that looks correct as well. Although I should think about this just for a second. So I wonder, so since these are stacked, because we're flipped in the ground chunk filling relative to our coordinate system, it's probably just that our edges are lining up in the wrong order. Meaning our top edge and our bottom edge are inverted because we're going in the wrong direction, if that makes sense. I want to see if that's actually true. Let me check and see if that's the case. Because if that was the case, yeah, that was the case. So basically it's because, again, of that Y flip that we always have to account for. But now we've essentially got infinitely tiling ground texture, which is nice. It's not a particularly nice ground texture because we're not actually doing anything intelligent with how we're actually compositing it, but it's pretty good to go in terms of where it's at. Now, what we could do probably to make this a little more straightforward is if instead of doing this random choice, we just made it always be grassy, for example, or always be stone. So let's say I did this like so. Oops. I could go ahead and... Ooh, you know what I just thought of too? I just thought of something fun. Well, all right, anyway. So if we go ahead and make it just one of them, it actually looks a lot better too. Like, you know, if we just stick to one thing, it certainly looks better. We still got, I feel like there's a little bit of artifacting potentially. Like, I feel like right in there looks a little odd to me. It doesn't look like what I might expect, but that could actually just be a thing. So I don't know if we're entirely bug-free yet. But yeah, it's starting to look pretty good. And you can imagine once we got some more splats in here than the ones that we have at the moment, we'd probably be good. And also, especially if we went in and actually had different patches, so there'd be regions that were grassy and regions that were, you know, stone and that sort of stuff, which is what we'll want to do eventually. Let's go ahead and put the tufts back in there. Let's go ahead and just say, all right, let's switch back to grass. Like so, and put the tufts back in, make sure the tufts don't have an overlap problem. And then we'll call this good for now, because this is a system that will sort of expand later on. So yeah, it also looks to me like maybe we want a little more, like they look a little clumpy to me as well, which I assume is probably due to our random number generator not being a random number generator, it's just a random number table at the moment, if that makes sense. So I guess I won't say that that's too much cause for concern, but you can kind of see, you can see the holes in the random number generator, assuming that's actually what that is, right? Assuming that isn't some kind of a, well, you know what else is the other problem with it? Is if there's alpha regions around those sprites, then you would have that problem. So, you know, we could also say, you know, give it a little bit of slop there just to see if that was something I could say to do. Casey, how much slop do we want here? But really, they should kind of touch, I feel like. That's not, you know, now that I'm saying it, since we're using the centers, I don't think that's actually true. Yeah, so I think that may just be our random number generator. It'd be nice to put in a real random number generator, but again, we gotta, you know, first, every little bit at a time. All right, so I think we're in good shape now. I think everything is reasonably, you know, is okay. So I'm going to say let's go ahead and start tackling our other problem. But before we start tackling our other problem, I'd like to have some way of seeing it happen more quickly. So what I'm going to do is I'm going to force us into a case where we have to... So I had to, you saw me at the beginning, I had to walk all the way up to find a place where we would actually run out of where we'd actually run out of tiles. And so what I need to do is I need to sort of exacerbate that situation. I want to make it so we run out of tiles right away so that I can see that our eviction scheme is working, right? Without having to do this huge walk up to the top. And so what I'm going to do is I'm going to go into that allocation where we said how many we had, and I'm going to drastically reduce the number, right? And furthermore, we haven't really decided how many of these we want anyway, but there we go. So when I run this, I'm hoping that now I won't have to walk very far before we run out of tiles, right? Although it looks like I guessed wrong, that still was relatively far. So let's try even less tiles. We'll just use 16 tiles now, and we'll hope that that gives us a quick out. So there we go. So we walk up here, and we're totally out of tiles right away, which is what we want. And so now our job is to make it so that we fill those in by reusing old tiles. Okay, so the first thing we need to do is we've already got a loop that does sort of this ground chunk filling. But the problem is this empty buffer thing right here. We basically don't have any way to get more empty buffers after we fill up the 16 that we've pre-allocated, right? So what we want to do is we want something that will tell us what is the least important one of the 16 chunks that are currently in existence, which of those would be the best one to replace. Does that make sense? And so there's a number of ways we could do that. I guess, like, for now, what I'm actually thinking, since we shouldn't probably be doing too much of this until we're on a more official engine pass with a little more knowledge, I'm thinking maybe what we'll do is actually do something where we sweep over the whole buffer, which is, again, very inefficient, but it might be the right thing to do instead of trying to put it in an LRU scheme or something like that when we really don't know what we're doing yet and it might be premature. So what I'm going to do is say, okay, we're trying to draw something here. So yeah, we're trying to draw something here. We're looping over this buffer. And while we're doing this loop, let's just keep whatever the least, the furthest from the camera actually is, right? Whatever's the chunk that's furthest from the camera, because we know the relative P here. So it's pretty free for us to just get distance from camera, right, for the chunk. It's pretty free for us to do that. We would just say whatever the length squared is of the relative position of this thing. And I'm going to just take the XY because I don't care how Z it was. So the distance from camera, I'm going to go ahead and say, all right, this empty buffer is actually just going to be furthest buffer now, right? And what we're going to do is just take whichever buffer would have been furthest from the camera. So when we loop over these ground buffer indices, and we go through here, oh, whoops, I'm actually computing the wrong place. I actually want to compute it in here, right? So if we found it, if we didn't find it, then we're going to take that distance from camera in here. So we want to do this, right? And again, that's a little expensive. And in fact, we could mitigate this a little bit by storing the last time that we did it. I'm not sure if we want to do that or not, but we could totally do that. Again, this is not supposed to be performance code yet. This is just something to sort of have it working so we kind of know roughly what has to happen. And then we're going to pull this out and we can fiddle with it when we get down to something where we're actually thinking more about our performance. All right, so this is our test buffer right here, right? So this is like buffer P, and we're going to get the centered chunk point for whatever its position was, right? Or actually, we don't even need that. It's buffer P, it actually already knows, right? It's actually just ground buffer P, right? That's what that is. So basically, what we want to do here is say, if it's valid, we'll do this way. If it's not valid, we'll immediately just take it, right? It'll be, if it's something that has never been initialized before, then that's going to be our buffer for sure. That's immediately what we would want to use because it means that there's nothing in it and that's going to be the best one to use. All right, so at the start, I'll initialize furthest buffer length SQ. And so the one that's furthest away at start is just going to be real 32 maximum, which I don't know if we actually have that. Did we ever define that? I want something that's never going to not be picked, right? And let's see what we've got here. Where are our type defs? They're a platform, right? I don't know if we did or not. It doesn't look like we did. So I'm going to go ahead and pull in the ability here for us to get the maximum real 32 value, right? And the maximum real 32 value in this case is defined in limits.h by the actual C compiler, right? So we can actually just get that for whatever this is like a synthetic header file basically, where the compiler is required to tell us for the platform we're compiling on what is the maximum float value. But we could even define it ourselves if we really needed to, because we know it's a float 32. So that's beside the point. But anyway, so I'm going to initialize it to real 32 maximum, which is the maximum value you could possibly have, which means we know that we will always pick something if we haven't picked something yet. So when I come in here, I'm going to say, all right, let's if this is valid. Oh, and I guess I'll set furthest in this case furthest buffer length SQ. I'll set it to 0 so that no one will get picked. No one will take priority over an empty buffer, because nothing will ever be less than. No length will ever be less than that, if that makes sense. Or further. Oh wait, I'm doing this backwards. We want further. There we go. So I've got these backwards. We want it here where we actually do it, so that the furthest buffer, nothing can ever be further than real 32 maximum. So when we do that rel p, and we take the length squared now, that's the distance from the camera of this particular ground buffer. We can then see whether or not that distance from camera, whether the furthest buffer length squared, I should call this like maybe like camera length SQ or buffer length SQ, something like that. So I've got buffer length SQ. If the furthest thing away is actually closer than the one that we're testing, then I'm going to accept that one as the new closest one, right? So this is just a standard, again, really, really simple, not clever, brute force way of finding whatever buffer would be best to actually replace here. And again, this code is horrible, just absolutely terrible, because it means we're doing however many there are here, like 16 of these or something. We're actually looping through all of our ground buffers every time. And it's just a testament to how fast computers are that we can even do this. And so again, this is not something that we really want to leave stand, but it's going to be something that I'd rather do a little bit further down in the engine so that we don't spend a lot of time optimizing something that may never get used exactly the way that it is being used today. So again, this is just avoiding premature optimization, but don't fool yourself. This code is awful, right? So anyway, let's go ahead and compile that and fix the compiler errors there. Float max, did I make a mistake there? Oh, sorry, it's not limits.h, that's for integers, it's float.h. My bad. So furthest buffer, it now can be filled like so, and that should do it. Now let's just double check that, because I kind of was trying to talk through that and I wasn't doing a very good job explaining it. So let's just try it one more time. And of course we don't really need found anymore, because furthest buffer would probably do it, I would think. Let's see here. Draw buffer, screen p dim. Oh, well, we kind of do need to know for drawing, don't we? How is this doing its thing? So we did this chunk center. We got the thing are the same trunk, length buffer squared, fill ground chunk. When are we actually drawing the ground? We're drawing the ground chunks later. So yeah, so we actually don't need to probably do that. Although when we do our found, yeah, so we don't need found, because found was just to tell us whether furthest, found was just to tell us whether we needed to fill anything here. But what we could do is just set furthest buffer equal to 0 when we find the actual valid chunk, and then this won't execute, right? So we don't actually need found. So let's just get rid of that. Now we're a little simpler. All right. So what we do is we start out saying that the furthest buffer away from the camera that we've seen so far is 0 length away, right? Which means that anything will be further away from this initial value. And then we say that furthest buffer, we make a pointer to save it in. We then loop through all the ground buffers, and we say for any particular ground buffer, let's see whether or not it's in the same chunk as the one we're looking for to draw for this location. Because again, we're looping through all the ones we want to draw for this screen. If it is, then we've found it, so we can just exit. We don't need to fill one, it's fine, right? But if we haven't, if that isn't it, then what we do is say, if it is a valid ground buffer, let's see how far away from the camera it is. And however far away from the camera it is, right, which is what we get right here, If that is further away than the furthest we've already seen, then we want to accept that as the new furthest buffer, right? Otherwise, not. Otherwise, we wouldn't fill this one. We'd fill whatever one we found before. And finally, if it's not valid at all, we want to accept that as the one to fill because we don't want to fill a buffer that's got contents in it. If there's a buffer that doesn't have contents in it, we'd obviously prefer to use that, right? And so I think that's at least the basics there, and hopefully that will fill things up for us. Let's see. Okay, so it looks like 16 is too few for the size that we're doing, so you can actually see that it's like overfilling itself. So let's give it a little bit more to work with. And then we also probably want to tighten up the bounds of what we're drawing there potentially, but yeah. So let's see. Let's take a look. Let's go to 32 and see how that is. But we may also have a bug in the loop, and that should tell us whether we do or not. Yeah, so that looks good. And now we should be able to walk kind of arbitrarily long as we go. And we should never run out of ground, right? It should be good to go. It's looking pretty good. It's looking pretty good, people. I like it. Yeah. So really, I don't know that we've got anything else we would really want to do with this at the moment. I mean, the only thing I can think of is that we'd want to do something as like with being able to put in where sort of grass is and where stone is and that sort of stuff. But I don't know that we want to quite do that yet. That's more of a world generation thing. But yeah, looking good. Looking good. Looking good. So, yeah. I guess we kind of have the problem now that we've come to a point where we want to start something wholly new, but I don't know. Oh, that's kind of interesting. So there's something we could fix, right? So do you see what's happening there with those, where these clumps got kind of overwritten? That's because we have two layers of ground, and we kind of want to always splat the detail splats on top of sort of the ground splats. So what we could do, right, is we could, if we wanted to fix that, we could go ahead and do something where we said, in fill ground chunk, we could say, do this loop, right? We want to do this loop more than once so that we do it once for each of them, which is a little onerous, right? But if we did that, if we split this up into two passes, right? So we did these first, right? And these second, that would prevent that sort of situation from happening, right? So let's walk a bit and then come back there. So that was one screen to the left and one screen down, right? So I'm going to walk back on the S and see if that fixes it, right? So let's go ahead back there. There we go. And so now you can see that we don't have that problem anymore. So that's kind of nice. And yeah, and we'll have to make a little more intelligence as well in the sort of the ground compositor to handle a lot of situations like that. But that's a pretty easy way for us to just fix it at the moment so that we don't have that particular problem. So yeah. Yes, I like it. So what time do we have here? Oh, we've got 15 minutes left. What should we do in 15 minutes? Because that's kind of an interesting question. I guess what we could do is start on handling multiple Z levels in those chunks. Because that's kind of, and then that would roll into tomorrow, I guess. Let's say that's true. And so something else that we could do too, you know what else we could do? This might be kind of fun. I don't know if this is a good idea or not, but one thing that we could do is we could make something that would allow us to whenever we reload the code in, because remember outside in our Win32 layer that does the code reloading, we could have something in there that was smart and told us when the code reloaded so that we could regenerate stuff when that happened. Does that make sense? That might be a good thing to do too. So let's do that. Let's do that. I think we should do that. So inside Win32 Handmade, and I'm going to open up the platform layer here. So when we pass through our game memory here, right? Because that's basically, we've got game memory, we've got game input. What I'd like to do is pass in maybe some things that say like, okay, executable reloaded or something like that, right? It's just a variable that tells the game whether the executable reloaded, and then inside here that allows us to that'll allow us to put in some debug code, for example, that we can use in a case where we want to do something special, right? And so what we could do is say, all right, if input executable reloaded, then what I want to do is go ahead and clear out all of the things that were in that cache, right? So I'm going to go in here and just say, all right, all of these guys, you now officially have nothing in you, right? Like so. So that'll just wipe out that ground cache completely, and off you go. So if we were to do that, all we'd have to do to implement that is in here when we do our reloads, right? Because we already have the thing that does the reloads. It does like load game code, this thing. We just have to look at how that code path works, and when we find that we have reloaded, we want to go ahead and set that input to be true. Now, load counter, I don't know what that is. Someone want to tell me what that was doing? I think that was something that we used to use for how often we would reload, but we don't use that anymore. So that's not relevant. So when we do our Win32 load game code, I'm just going to do the simplest possible thing here and say that new inputs executable reloaded now equals true, whereas normally executable reloaded will equal false, right? That's it. Really, really straightforward. So basically it sets it to false, and then if it actually does its reload, then it reloads. Now, I don't know if we return anything more specific here. In fact, you know what I could do? I could make this actually be equal to that, but I don't know. We'll leave it this way for now. So there we go. We've got that going. So we open up the game, and here we are. And so now what I'd like to do is I would like to make it so that I can change the routine, so I can change the routine that does that compositing. So let's say I go in here and into that fill ground chunk. What I'd like to see happen is if I just turn off the splatting of the grass chunk, the grass tufts, for lack of a better term. If I turn that off, before if we recompiled, nothing would have happened. Now if I do it, I want to see that change. And hey, it did. That's pretty darn awesome. That is just pretty darn awesome. You got to admit that's pretty cool. Yeah. Live code editing is the way to go, man. It's so much fun. Even if you don't ever use it for anything productive, it's still just fun to just sit there and kind of play with so that you don't have to wait for your turnaround and so on. So yeah, that looks pretty good to me. I'd also like to go double check. I'm a little concerned that we're kind of drawing too much. Yeah, so let's, I've got a couple other things we can do since we've got some time left. I want to know why we're actually drawing so many, why 16 wasn't enough. I'm going to make those draw rectangle calls that we have, this the draw rectangle outline stuff that was happening here. I'm going to actually make it so that this ground buffer thing, I'm actually going to make that happen up above here, right? I'm going to make that happen up here, which is actually bad. Like, it's not actually what we want to do, but I want to see those debug regions over it. So to do Casey, this should really not be here exactly. Well, that's not actually true. So really it's this thing. This should really, you know what? The only reason I'm even saying that is because this thing will fill chunks and then this thing will draw them. So you want to fill the chunks before you draw them, but this is going to be on a separate thread anyway. So I don't even know why I'm notating that. It does not matter at all. So let's see how many there actually are on the screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So actually having only 16 really wasn't enough. So yeah, 32 might be too many, but 16 actually legitimately wasn't enough, so I'll give that to you. So that's okay. And there we can see the boundaries nicely, so it's all good. Yeah, so I think we're in pretty good shape there. I'm totally fine with that. Now we have another issue to address, which is our Z layers, but I think maybe we'll start on that tomorrow. I don't want to start on that now. So yeah, is there anything else that I kind of wanted to do here? I do wonder if these chunks are too small now, although based on the number of entities that are in here, 1, 2, 3, 4, 5, 6, 7, 8, based on the number of entities, I would say no, probably not. I mean, I don't know. We'll have to see what our memory footprint looks like and how we're doing when we start there, whether these are too big or too small for ground chunk sizes. But that's pretty good. That's pretty good. I'm happy with that. Okay, so now I'll go ahead and move this back below it for now. Or actually, I guess I won't. I'll just comment this out. And then if we want that again, we can turn it back on. But that should do it. Alrighty then. Happy day. We are now at our giant ground texture is there. It is happy and it's working well. So that's good news. And I think we can probably call it a day. We can probably go ahead and get that Q&A started here a little bit early. So let's do... Is the bot operational? The bot is back. The bot is back, people. All right, it is time for the Q&A. And the Q&A is for asking questions about the code we just wrote. Please prefix your questions with Q: so I will see them, and try to keep it to stuff that we've actually done programming-wise. So there. Jazzy Josh, are the randomly generated floor tiles being cached yet? Yes, they are. They are being cached. Do you think having things in place like static cast to put more checks, e.g. into pointer, is useful over standard C-style cast which just ignore all type checking? Wouldn't a static cast have found that bug at the start of the stream? Again, like anything that is of that nature, you have to decide whether adding new features into the code base is worth doing or not, right? And there's even additional reasons why you would care about that today that aren't necessarily true in the past either. And one of them I point out is I think C++ isn't long for this world. I do not suspect that we will be programming in C++, 5 years from now. I suspect we will have moved on to a C variant like maybe hopefully John Blow's language that's has the C stuff in it still, but not the C++ stuff. And I think it will be much easier to port code bases to the non-C++ language if you don't use all kinds of C++ garbage, right? So I try to keep C++ out of the code base as much as possible because I think it's probably going to go away. If you know you're going to use C++ and you love C++, then there might not be any reason not to introduce those. But I tend to weigh those things relatively heavily, right? Putting that aside, in this case, that's a bug I've literally never had before. So in my mind, that's a stream bug. And so, do we want to do it on the stream? I don't know. It's probably not necessary. That's really not that big a deal. We would have caught it. I don't think that's a particularly important bug to guard against because we don't do it that often. It's only the initialization of the arenas, which only happens twice. So I'm not that concerned about it. And it's a bug I've never had before in regular code, so it's not a typo that I actually make. And like I said many times, you only want to spend time guarding against things you actually do, which may be different for you than for me. So if you find yourself actually making mistakes like that fairly commonly in your actual code, not when you're trying to talk and explain things, but in your actual code that you do, and you find that they're hard to debug, that would be a good time to introduce additional checking. If you don't find yourself making those errors, then you're just wasting your time. It's a good idea not to waste your time. So that's the advice I give on basically all the things that people ask about that are of that nature. It was like, figure out how much time you spend debugging those bugs. And if that amounts to a significant amount of time, then consider steps to mitigate them. If not, then don't. And you'll note that we've gotten through 87 hours of programming here without ever having that bug before. So, and we've had only one of them so far. So if we never have another one of those again, I would say it would be a really bad idea to start introducing random stuff like static const that we don't actually need. Whereas if we start hitting these fairly regularly and we have another one next week and another one the week after that, then that is the time to say, hey, this is a bug we do. Let's take care of it. Do you think the clumpiness is actually due to splat distance from the center of the chunks? So I don't know what it's from, but I suspect it's from the random number table being awful, right? And we could check that quickly if we really wanted to, right? So one way we could check that, right, is by using C's random number generator, which is not great, but it doesn't have the problems of our random number table. So if we wanted to, I'd have to get back. Let's see here. Let's see. I'd have to get back our very clumpy grasses. So I'd have to crank this number up. And what I'll do here is I'll just crank this number up to like a really absurd number, right? So we can kind of see it. Let's see here. It's kind of hard. It doesn't look that clumpy. So you know what? I think that what we were seeing was actually the fact that we weren't drawing these on top. That's what we were actually seeing. So I take it back. It wasn't the random number generator. It was that bug that we fixed where we weren't drawing these in a second pass. So the next thing that abutted would overwrite, some of the grasses. So it's fine. Our random number table is still lousy. Like when we switch to a random number generator that's good, we'll get some benefits, but it looks like this is not actually a problem. So we'll go back to something. What's a good amount of grass? I don't know. Let's say that much. Of course, normally we would only want the grass to be on the grass, but that's a story for another time, I suppose. Although I guess we could do that pretty easily here as well. Do you know why the trees are wiggling around sometimes? Yes. So we don't have a renderer right now. I know that's a weird thing to say because there's stuff on the screen, but all we did is make a very simple blit bitmap call, and that's all we have. So you notice there's a bunch of artifacts that you can already see because we don't have a real renderer. That's something that's coming up later in the stream. And so one of the artifacts you see, for example, is we don't sort anything. So like I can pass behind things sometimes, right? Like that. And that's purely because there's no sorting. It just depends on what order the entities were getting dealt with, right? That's it. And so that's an example of something the renderer will fix. Another thing the renderer will fix is we're not subpixel accurate at the moment. So the reason the trees are wiggling, like you can kind of see that, is because they are snapping to integer coordinates. They are floating point positioned, but they're snapping to integer coordinates. And when one rounds up to the next integer coordinate, but the other one hasn't yet, right? You see their distance change a little bit. And so that's another thing that the renderer will fix for us, because we will be subpixel accurate in our renderer, and you will get a nice smooth interpolation there, which is, it fixes that problem, but strictly speaking, we could fix this problem another way. It's just we don't actually want to. We want to fix it by actually doing the subpixel stuff, because there's, that makes for motion that's much smoother on things that are slow moving as well. So if that makes sense. What is causing the lag? Oh, okay. So if you haven't been following for the past couple of days, then you don't know what that lag is. So that lag is right now, well, we've got two things. There are two reasons for the lag, if you will. And I assume you're meaning that pause right there, right? So there's two reasons for it. The first reason is because we are not generating those background chunks on a separate thread. We just generate them right when we decide we want them. And it's an expensive operation, so we get lag. Normally what we'd want to do is overlap that processing so that it doesn't hurt our frame rate, right? But that said, it really isn't enough work to actually make the lag that you're seeing. So the reason that you're actually seeing the lag would be there, it'd just be a minuscule amount and it wouldn't actually affect the frame rate because we're not overlapping, right? But the reason you're actually seeing it here is because we have really unoptimized code for producing the ground segments. They're calling a bitmap blitting routine, like the same one that's blitting to the screen, which is completely unoptimized and is the slowest possible thing you could ever imagine for blitting a bitmap to the screen. And so really, also, we're not even compiling it in release mode. So if we were to compile in release mode, we'd also speed up a little bit. So for example, if we were to say in build.bat, if we wanted to change our -0d here, right, to -02 to get some measure of optimization happening in the code, you would notice that the lag is reduced, right? You can see that it's a much shorter hiccup than it was before. But that's, again, that's kind of more about just the fact that we haven't done any optimization on the code. And so that's like why the lag is as substantial as it is, because it's running very slow code, right? Are there still places where the background color shows through the ground tiles? Probably not anymore, but we haven't done really the things that we want to do to guarantee that, but those have more to do with actually, those have more to do with how we generate the ground tiles than anything else. But if you want to be able to check that, one thing we can do is put in a hideous pink. It's not perfect, but it would let us see a little bit more readily where we were getting problems. It's not a perfect check, honestly, but you can kind of see now that you're not seeing much background through at the very least. But you can also see when we don't quite have the tiles filled yet, when they come on the screen, you can see them kind of flashing in there, right? And similarly, what we'd probably want to do eventually is we're going to need to do something that kind of predicts, it asks for tiles that we haven't needed on the screen yet, right? That's something we also want to do. But yeah. Is this chunk code already prepared for adding holes to the ground? Holes that could be any size? Yes. Really, all we have to do is then cut out the alpha later on, right? So if we wanted to, for example, I mean, I'm just totally going to make up something here, right? But if I walked back to the starting room here, I think this is the starting room, right? Yeah, nope, not quite. If I walk back to the starting room, eventually, well, I'll just restart. If we wanted to, we could add holes already, right? It's pretty easy. So all we need is there's a draw bitmap, right, routine. We need a draw bitmap that can basically draw solid alpha. It's not really, it's like a bitmap insertion. And so what this would be is, it's a little hard to explain, but let me just copy this routine and I'll show you what I mean. So if we did something like draw mat, okay, and in here, if we changed what we meant by the RG and B colors that are in the buffer, right? If we made this cut out a hole in the alpha, instead of filling it in, that would allow us to punch holes in it, right? And so just a simple example we'll start with. Let's say we did something where we had A equals 1.0 minus whatever that source alpha was, right? Something like that. Is that right? So RSA 255, yeah, something like that, minus SA. So that would be, oops, 255 minus SA. And when we were drawing in here, maybe we don't actually touch those colors. We just need to multiply. So yeah, I'm trying to figure out how to do this relatively quickly. But so we want to make a real alpha composite op here. So I'm just sort of not thinking this through half at all. But let's say we take the destination alpha, right? And we multiply it by the inverse source alpha, right? So that it reduces it down to what it. So if the source alpha was being drawn brightly, it would get very dark on the DA, and we don't add in any color at all. So all we're doing is strictly dimming, like removing power from whatever is being written in there, if that makes sense. So if we do that, then what we've got is the ability to matte something out. And so I'll show you how that kind of works, right? So if we compile this and I go into that ground chunk generator thing, right? Fill ground chunk. If I just in the middle of the ground chunk or something, well, actually, you know what I could do? Let's draw the ground tufts as mattes, right? And I'm sorry, I kind of did this hastily, but so do you see what that did, right? That allows it to punch holes that will see through to whatever's underneath. And remember, we drew pink behind it. So yeah, it's real easy for us to add holes. We just have to have an idea of like a bitmap that we want is like what the hole's shaped like, and then we punch it through. Really, really basic stuff. Yeah, so nothing complicated there, if that makes sense. I should put in the draw matte routine, because the draw matte routine, I didn't really think that through. We should put check this math. Oh, hey, it already has one from the previous one. But I did actually look up to see if this was correct, and I believe it is. So we could validate that later. But yeah. Could you make code that ensures a certain frame rate, but uses extra available time to generate the ground textures in the background? Maybe you're generating a low quality version first to avoid having no texture at all. Yes, you could do that. Those are two separate things, right? What the lower detail versus higher detail and the certain frame rate thing. The reason why you don't generally want to write code like that anymore, and this is true especially now that the Raspberry Pi has gone 4-core, is you need something for your 4 cores to do, right? Because you're going to have 2 cores at a minimum. Most gaming machines are going to have 4 cores. And so you typically want to have background stuff. So you typically need to have extra threads doing things. And so putting it on the main loop and doing it as a frame rate guarantee, a frame rate limited thing, just isn't very leveraging of the way processors work. So you typically want to have a bunch of tasks that you do, and they kind of are operating on multiple threads as a way to use up that CPU time that's sitting there. If that makes sense. All right. Looks like we are out of questions. Is it true we are out of questions? It may be true that we are out of questions. I think we're out of questions. Well, if we're out of questions, then that's it. We're all good. All right, folks. That is another Handmade Hero. It's working pretty good now. I'm liking that. We got some graphics in there. It's always good when you add graphics. A day when you add graphics always feels good, looks good. It's fun. So tomorrow we can start on our final Z-layer stuff. Maybe, it's going to be fun to have rooms overlooking other rooms. So I think that'll be a good push. We'll start it tomorrow, and I'm sure it'll go next week. We'll be mostly doing that because that's a lot of work to get all that stuff right that we've kind of been sort of working towards, but it's got to all come together, right? But we finished that round of generating ground textures, and we did it in a way that allows us to generate ground textures at as many Z levels as we want, which is kind of cool too, because that cache can just cache any tile anywhere, really. So it's kind of handy. But anyway, enough about that. Thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. I hope to see you back here tomorrow, same time, same place, 5 p.m. Pacific Daylight Time on Twitch TV. Come a few minutes early if you want to chat. I'm usually here about 15 minutes early, actually. If you would like to follow along at home, you can always pre-order the game on handmadehero.org using the handy-dandy pre-order button. So if you want to check that out, you could do that and get immediate access to the source code, which you can download and play with, which is a good way to learn if you like sort of learn by experimentation, which I highly recommend. We've also got 3 other things to check out. One is the news and forum site, which basically has a place to ask questions, ports to Mac and Linux, and a annotated episode guide. So it's a lot of good stuff you can use to help learn from the stream. It's pretty cool. We also have the Patreon. If you want us to help support the video series, you can subscribe to that. The videos are free as always in our archive. So that's just if you're just nice and want to help us, that's a very nice thing to do. And finally, we've got the tweet bot that tweets the schedule. Highly recommend checking that out and subscribing to it potentially if you would like to know when the stream is every night, because sometimes it moves around. And especially now when we're trying out a new time slot. We used to be at 8 p.m. Pacific Standard Time. We're trying out 5 p.m. this week, and we may switch to that permanently. So we'll see how it goes. Anyway, thank you very much for joining me, and I hope to see you here tomorrow. Have a wonderful, I guess it's Friday tomorrow, is it? I don't remember. Abner Coimbre, if I'm saying that right, one of our fearless moderators, had a thing at the beginning where he eloquently stated the order of the days that would occur, and here I am not remembering. I think tomorrow's a Friday. It is. Tomorrow's a Friday, so have a wonderful Friday, and I hope to see you tomorrow evening. If not, have a wonderful weekend. Take it easy, everyone.